Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to look at universal design in computer science. Last semester we looked at the idea of universal design in general, so in this semester I want to talk about universal design in computer science. I'm also going to be talking about something that's my own research, so this is stuff that I've looked into because I want you to know researchers are normal people like you and me. It doesn't take any special set of skills to be a researcher, particularly in education kind of topics. All you have to do is have an idea and write a paper about it. So this particular area, universal design in computer science, is something I've written several papers about, and it usually goes down well when I give a talk about it. So we'll recall that the 7 principles of universal design developed in 1997 by a built environment group are equitable use, flexibility in use, simple and intuitive perceptible information, tolerance for error, low physical effort, and size and space for approach and use. Now, I would argue, and I always argue, that although those 7 principles are the guidelines by which universal design is achieved, designing for everybody, my take is that equitable use, which is called principle number 1, is actually universal design. Equitable use means anybody can use it equally. So if anybody can use a design equally, then it is universally designed. That's it. So that is the whole shooting match there, in my opinion. How we achieve equitable use, though, is through the next 4 principles, which is flexibility in use. That is, different people can use it differently, or you can use it for different things. That it's simple to use. That the information you need is clear and understandable, and that if you make a mistake, the design tolerates the mistake and doesn't break in pieces. So I see those as the general principles for realizing equitable use, or the overall philosophy. And then the bottom 2 principles I see as simply the principles for realizing that philosophy specifically within the built environment. So these aren't principles that we would think about as software developers, low physical effort and size and space for approach and use. They don't make sense as philosophies or principles in terms of that. So what I think we should do is get rid of them. So we're going to swipe them away. Boom. And we're left with 5 principles. And let's add in 2 more principles instead. So the 2 principles I want to add in, replacing size and space and low physical use, are the use of patterns and consideration for users. So these are my 2 principles that I've created. This is fairly cutting edge stuff. There aren't any other computer scientists who are suggesting any other 2 principles yet, but there will be in time. But we're ahead of the curve on this. So if they are now the new 7 principles, let's try and understand what they're about. As I see it, they are, in essence, all about the user experience. When we develop software, we want software to be equitable, we want software to be flexible, we want it to be simple, we want it to have clear instructions, we want it to tolerate error, we want software to use patterns to make it easier for the user to access, and we want to have consideration for the user. So I see these very much about the end user and focusing principally on the user interface. But I want to think about the code itself as well, because as we know, the interface is 10% of the code, and the code we develop is 90% of it. So let's think about our sorting code for a minute, our merge sort or our bubble sort or any of the sorts we did. All that the user gets is maybe they type in an array of values and then it prints out the output, which is the array sorted. That's all they see. They don't see the merging of values or the swapping or any of that stuff. But that is really important for us as developers. So I think not only should the interface itself be universally designed, but we should think about making sure that the code is universally designed. The reason I think this is important is because whatever code you write, you probably won't be the person modifying it. You'll be in a job for 5 years, you'll write a bunch of code, then you'll leave, then somebody else is going to take over and have to modify that code. So the better designed the code is, in terms of the use of variable naming and things like that, the more likely it is that the person who succeeds you will be able to understand the code. Why do you care about the person who succeeds you? Because if everybody did this correctly, then when you take over from somebody else, their code will be easy to use as well. So I'm proposing that the 7 principles should be used as a measure or a metric of how effective our code is in terms of being easy to use. So if we think about the code, it's going to be like that, but we can make that code either really easy to use for somebody else, or we can make it complicated. Which do we want? I think we want to make it as easy to use, as universally accessible as possible. So what I think is, we can think about the end user guidelines, and we can also think about developer guidelines. So underneath each of the 7 principles, there are existing guidelines, but they are end user guidelines. So what I've done is created a series of developer guidelines to parallel the end user guidelines. So let's look at the first principle, which is equitable use. Since 1997, there have been 4 guidelines in terms of what the end user experience should be like. So the guidelines are: provide the same means for use for all users, identical whenever possible, equivalent when not. Avoid segregating or stigmatizing any users. Make provisions for privacy, security, and safety equally available to all users, and make the design appealing to all users. So they are end user. That's how, if I'm developing code, how I want the user to experience it. But if I'm writing software, here are 4 guidelines that I should include or think about. Provide a range of development environments or IDEs. Ensure that all the necessary assistive technologies are available that are needed. Provide versioning software, document backup facilities, and undelete features where possible, and ensure that the software is as readable and as clear as possible. So each of those guidelines, as developer guidelines, mirrors one of the end user guidelines. Next one is flexibility in use. So the existing guidelines say, provide choice in methods of use, accommodate left-handed or right-handed access, facilitate the user's accuracy and precision, and provide adaptability to the user's pace. So again, that's if a user is using your software, what it should be like. So then to think about it in terms of development environments, again, this first one is the same again. Provide a range of IDEs in development environments. Next one is to provide a range of input devices if possible. So keyboards, voice synthesizers, touchscreen interfaces, whatever, to allow different users to input the information in different ways. Provide coding standards for checking tools, provide testing tools, things like that, and develop your software in a modular, component-based way so that it's easier for others to understand. Our next is simple and intuitive, and that has 6 guidelines already. Eliminate unnecessary complexity, be consistent with user expectations and intuition, accommodate a wide range of literacy and language skills, arrange information consistent with its importance, and provide effective prompting and feedback during task completion. So as well as those, when we're developing software, I'd like us to think about if we're implementing features that are complicated, try and make them as clear as possible. So don't obfuscate or make it unnecessarily complicated. Try and make all modules in terms of implementation as clear as possible. Be consistent with the developer's expectations. So think about what the next person is going to expect and then accommodate that. As well as that, accommodate a wide range of literacy skills and language skills. So if I'm putting comments in code, assume the person reading it, English is their second language. Include little ASCII diagrams as well. Be kind to the next person using the stuff. The same as the guideline, arrange information consistent with its importance, and then definitely use software libraries where possible. So rather than you implement an encryption methodology, if you use an existing software library that does encryption, the person who takes over the code from you doesn't have to troll through your code, try and understand what it's about, because you're just calling a library called encrypt or something like that. In terms of perceptible information, which means easy to read, in terms of the user interface, again, we say use different modes, pictorial, verbal, and tactile, for redundant presentation of information. So use pictures plus words. Maximize the legibility of essential information. Differentiate elements in ways that can be described So that's to say, make it easy to give instructions or directions and then provide compatibility with a variety of techniques or devices used by people with sensory limitations. So then in terms of code, I would say A, and this is possibly the most important guideline, comment your code a lot. Comment your code proficiently, prolifically, completely. Comment the heck out of your code, because it'll make it easier for the next person to understand what your code is about. B, use clear variable names and module names. So don't call the variables X and Y, call them interest rate or tax rate or whatever, and the module names. Build in help features into the code if possible, and provide compatibility with a variety of devices for people with sensory limitations in terms of developing the code. The next one is tolerance for error. Our guidelines as the RR arrange elements to minimize hazards or errors. The most used elements, most accessible hazardous elements eliminated or isolated or shielded. Provide warnings of hazards and errors, provide fail-safe features, and then discourage unconscious actions in tasks that require vigilance. So in terms of software, I would say develop software using the principles of defensive programming, and have a look up what defensive programming is. Catch errors where possible, and we'll be doing the try catch or the try except block later on. Give detailed and clear error messages, always make the error message as clear as possible, and avoid using global variables that can cause side effects in different modules. The use of patterns, so this is a new one that I've created. So I've created both the end user guidelines and the developer guidelines here. So in terms of use of patterns for end users, provide repeated themes in terms of navigation, provide repeated themes in terms of functionality, provide standard screen formats, and provide visual cues. So that's for the user, and then for the developer, use software design patterns as much as possible, use the same coding approaches to similar problems, use the same variable standards and naming standards for modules and variables, and use standard library functions. And our last one is consideration for users, and again, I made up these end user guidelines. Understand the user's needs, consider the use of personas, consider the end user's primary and secondary languages, and provide lots of help features. So for developers, they should develop modular code to help the successive developers, develop easily extendable code, adhere to coding standards, and then comment complex elements of the code and refer to design documents. So as you can tell from this, a lot of the guidelines overlap between the different main principles, but that's okay. It doesn't hurt to reinforce the idea of commenting your code or naming your variables right, or using modularity as much as possible. These are just some rules or guidelines I'd like you guys to think about when you're coding. And just have an awareness, you are not coding for yourself, you're coding for the next person who comes along who has to modify your code. Sometimes what I say is you're actually coding for the printer, because if they don't understand what your code does, they'll print it out in the printer, and then they'll write in pen all over your code trying to understand what it's doing. So if you can think about what your code would look like if you didn't know anything about it, that'll help in terms of the next developer along who's going to be modifying your code. Thanks very much. We'll see you on the next episode.